So now we're into lesson 2 of Unit 5, and this is going to deal mostly with writing constructors. We've used constructors before as you're interacting with a different class. Often you want to initialize the instance fields to several variables. This is how we're going to create an object reference to that class. Data would be stored, any methods that might be a part of it. Everything takes place here. So as we see here, talking about the state of an object, that's like attributes, values. We say that there's has a relationship. Okay. So if we look, for example, at this zombie dog that I'm creating here, this zombie dog has health points, attack power, ability to be labeled as a mutant or not. And in the default constructor, the health points are initialized to 0, the attack power is 1, and it's not a mutant. This would be the current state of the object, all of those particular values describing those instance fields that belong to the zombie dog. So when I say what state does ZD1 have, okay, well, its state had sort of like 3 things, right? It had a health points equal to 100. It had an attack power of 1, and it wasn't a mutant, okay? His mutant was false. So that's its current state. We could change some of those things, but that's the current state is whatever the values of those instance fields are. In terms of the has a, so it has a health points rating, it has a attack power, it has a is mutant label. Okay. Constructors are used to set these individual states. What should include initial values for all instance variables? Remember, you're going to start writing constructors now. So more than just interacting with constructors of another class, you're going to write the constructors that belong to a class. So in addition to the zombie dog, I've provided a zombie cat class. Okay. And I've asked us here to attempt to write the default constructor for the zombie cat. Now, some things to keep in mind, okay? Like it says right here, a constructor should include initial values for all instance variables. That's not a mandate, okay? The word should, right? It's just implying that you should do it. It doesn't say that you have to. In fact, if you didn't, there's some peculiar things that would happen, and we'll talk about those, okay? But we're going to go write that constructor for the zombie cat class. Some other things to keep in mind, right? One of the things we saw in our video yesterday was that constructors should be labeled public. So the first thing I should write is public. Something that we learned in Unit 2 is that all constructors have to have the same name as the class, and they never have a return type. Okay? They never have a return type. So you never put here like void or string or int or double or anything else. You just go straight from public to the name, which has to be the same as the class. The default constructor is typically referred to as your no argument constructor. Okay, so like we don't include any parameter values in here. All right, and then like they said, we should initialize all of these. So I've put some notes here. I've said health point should be initialized to 100, defense level to 1, and is evolved to false. If it didn't say that, and I guess we'd have to make up the values, or it'd be kind of like up to us, our choice. But I'm going to go ahead and set health points to 100. I'm going to set defense level to 1. And I want you to notice as I do this, there's 2 very important things. One is I'm taking advantage of the fact that Java initializes from right to left. So when there's an assignment taking place here, like I'm assigning 1, I'm assigning 100, I have to put those values on the right and allow the assignment to take place from right to left. The other thing I'd really like to point out is that I never redeclared any of these values. Right? If I had redeclared, like say right here as int, I would have actually created a second variable that would have been local to this constructor. And like we've seen in loops, what would happen to that variable is it would get destroyed the second that the constructor call ended at that closing brace. So in other words, what good would it be to you, right? If you created the variable and then just destroyed it seconds later, What you wouldn't be doing is you would not be assigning 100 to this variable, right? So that's what's happening right now when I get rid of it. I'm splitting it up. Here I'm declaring it, but later when somebody invokes my constructor, then it will get initialized. Okay, it already exists. The variable exists as soon as you reference a zombie cat object, but the constructor actually provides that initial value. Okay, and so if we came back to our main right now, we should be able to take this right here and hopefully we can run this. Okay. And let's see. Oh, by the way, remember earlier I was talking about the state of the zombie dog. We could have checked that right here. I didn't catch the fact that I put that print state method call there. So we can check the state of the zombie dog, just make sure that we were right. 101 false. And now that we've written the default constructor for the zombie cat, notice that it got very similar set of values. We could have made those different. We were just following the directions. All right, constructor parameters are local variables to the constructor and provide data to initialize instance variables. Okay, what that's talking about is in the last example I showed you, that was a no argument constructor. So it didn't have any values passed to it. But if we had passed parameters to it, they would be local to that constructor. And really, the only thing that they would be of use to us for is to initialize the instance variables. So to illustrate this, let's go try to write the initialization constructor for zombie cat. And we're going to use those values there. They're going to get passed in though. So we're not actually going to reference any of these values as we go write that constructor. We're just going to make it possible for this link to happen. So like it says, we're going to write a 3-argument constructor that accepts 2 int values followed by a Boolean. That's a little different than zombie dog. That's okay. Use the first int to initialize health points, the second to initialize defense level, and the third to initialize is evolved. All right, so what this means is we're going to write, again, public, because we learned yesterday all constructors should be public. Not going to be a return type. And the name is going to be zombie cat, the same as the class. But I'm not going to leave this blank. In fact, I can't. You can't have 2 constructors with the same parameter field, right? That's not a proper overload. So instead, I'm going to declare 2 ints and a Boolean, okay? Doesn't have to always be that way, but for this problem, it does, right? 2 ints and a Boolean. Now, when I declare those ints and Booleans, I can't just write int, Boolean. That's not an actual declaration of a variable. I need to declare a variable and give it a name. The name is totally inconsequential. This is a local variable only used to initialize the instance fields. As soon as the constructor's call is over, this variable is going to be destroyed. Okay, so like if we have a little break structure here, right? As soon as we get done with this constructor call, the variable will cease to exist. And I'll show you that in just a minute. Now, just like before, we're looking to initialize these values, the same ones, health points, defense level, is evolved. We maybe saw ahead of time what those numbers are going to be, 75 for true, but we're not limiting ourselves to that. Another person might put 53 and false, okay? What we're going to do is we're just going to declare, like, again, this is just a local variable. So like right here, maybe I call this like health, okay? I don't want to call it health points because if I had 2 variables by the same name, things would get a little tricky. We're actually going to learn how to handle that later next week. Maybe I would call this one just defense. And maybe I'll call this one Evo. All right. And now what I'm going to do is, what I've done is I've said that when you're going to create a zombie cat, I'm going to temporarily declare for the purpose of this constructor 3 variables. Okay. The user is actually going to initialize those variables. So whoever makes the constructor call is going to provide the initial values. If those are primitive, then copies of them are going to be sent over to the zombie cat class, and they're going to initialize, like health would be initialized to 75 in this example. But another example might initialize it to 50. Okay, So I don't know that this number is going to be 75. So what I'll do is I'll just use health. Health is going to hold on to whatever that number is. Defense is going to hold on to a value. Okay. And so is Evo. And again, we're using the fact that Java is going to go from right to left. So these temporary placeholders are holding the value that the user picked. That value gets assigned from right to left into the permanent instance field. Same way it was happening up here, it's just we don't see the actual number. We're doing it through a placeholder in this local variable. Now, that variable gets destroyed the minute this ends. So watch what happens. Like, see, imagine I came right here and I wrote help. That's actually going to crash everything now. It's going to tell me that it can't find that symbol. Okay. So watch the error message that I get. It says cannot find right here health. And so the reason it couldn't find it is, again, like we saw with for loops, if you declare something in a substructure like this, like in this case, this constructor, as opposed to like a for loop declaration, that variable only exists within this little realm right here. As soon as we're out of that constructor, it actually destroys that variable. So you can't access it down here at line 37, which is what I was being told in this error message. Now, health points was not declared within any type of method. That's what makes it so special. It's an instance field because it doesn't belong to a particular method. It belongs to the entire class declaration. So you can use it throughout. Now, we initialized it here, but that just became its value, okay, that was assigned to it. Or maybe we're going to initialize it here, but it's been declared for use throughout the entire class. That's what makes it special. That's why it's an instance. All right, so this is my initialization constructor. Okay, if I went back to the main, what I could do is I could turn this off here, like, or on, I guess, and now I should be able to create this new zombie cat, ZC2, and this would be its state, okay? 75, 4, and true. That would be the state of this particular zombie cat. When a no constructor is written, Java provides a no argument constructor, and the instance variables are set to default values. All right, we've kind of seen this before, but what this means is if we went back to zombie cat, and let's say I comment out both of these, okay? So I'm going to put a block rem. Oh, I should have gone a little higher, sorry. Well, no, I think we have to do this. We'll put a block rem around this one, okay? That was our initialization constructor. And we'll put a block rem around this one. Now, on the main, I'm going to have to make a little change, okay? We can't use this one anymore. So this guy can't happen now. We've gotten rid of all of our constructors. However, even though I got rid of both constructors, I can actually still run this code, okay? But here's the difference. We won't see 100 pop here, and we won't see 1. We will actually still see false. It has to give a value. So when Java provides this default constructor, it has to put something there. So it has some built-in place default values that are ready for it. Integers, doubles, they become 0, okay? Any Boolean becomes false. Anything else that we deal with is going to be an object. With the only primitive types we need to know are int, double, and Boolean. So 0 for int, double, false for Boolean. Anything else we deal with in our course is going to be an object-based, okay? And they all get set to null. So if we had a string or a zombie dog or a student or something we had written, they would be set to null. We would actually see the word null print right here. We'll encounter that before this chapter, okay? If I tried to use my other zombie cat initialization now, this wouldn't work because that constructor no longer exists, right? I turned it off. I also turned off the default constructor, though, right? That's what's so weird about this. I didn't just turn off the initialization. I actually turned off the default constructor. So why am I allowed to do this? Well, again, if you don't put any constructor in your class, Java will give you a no argument default constructor. And it will choose the values for all of your instance fields. Notice I never initialized these variables. Previously, okay, if we tried to use a variable that hadn't been initialized, we got an error message. It said variable might not have been initialized. These variables play under slightly different rules. These are instance fields. So technically, you don't have to initialize them because Java will do it for you even if you don't. And it will put them on their default values. 0 for int double, false for Boolean, and null for anything else. Okay, that's why I was able to print these even though I never initialized them. A little bit different when you're talking about an instance field. All right. When a mutatable object is a constructor parameter, this is some high level stuff. I don't think we're going to ever encounter something like this on a test question, but maybe. Okay. The instance variable should be initialized with a copy of the reference object. In this way, the instance variable is not an alias of the original object, and methods are prevented from modifying the state of the original object. Now, we're going to talk about this more later in the year when we talk about like passing by a value or passing by a reference. And this is an example of it. It's some tricky stuff. It has to do with this idea of aliasing an object, okay? Like we saw a little bit of in Unit 3. So I've got a little code sequence here. And what I've done is I've created a zombie cat and a zombie dog, okay? Easy enough. Then what I did was I put them into something called the battle arena. Yeah, this is me trying to be creative. All right. So what is the battle arena? All right, it's a fight to the death. Okay. 2 zombies enter and 1 leaves. We've got a fighter cat and a fighter dog. Now, I've initialized them slightly differently in my battle arena constructor. When I pass the zombie cat and the zombie dog in to the constructor, okay, cat, I just said, oh, go ahead and copy it. Okay, so make fighter cat equal to the one that comes in. That's risky, okay, because what actually happens here, this is weird stuff. But when you do this, when you send over ZC, it's actually sending over that weird memory address, which is again just some sort of string of random numbers and whatnot, binary digits, whatever. It's not the actual values. It's not holding on to the health level and the attack power and whether or not it evolved. It doesn't know any of that. It's just holding on to some random address that can take you to that information. But what happens is if we give that address away and we hand it off to somebody else, like I'm doing here, then now I've created an alias. Fighter cat, in a weird way, is simply an alias, okay, to ZC, the same zombie cat that lives over in the main method. Now, even though they're in 2 different classes, it's actually an alias of it. And so what happens is, now I did it a little bit differently with zombie dog. Okay, with zombie dog, what I did was I made a copy of the attributes of zombie dog. I took its health and I took its attack power, and I just took copies of those numbers. And then I made a brand new zombie dog reference. This is a brand new reference right here. And so as a result, that means that fighter dog is not an alias to ZB because it got its own memory address, its own reference. There's 2 zombie dog references now. Okay, so now here's where things can get really weird. Somebody on the outside of this class could mess with the zombie cat. They couldn't mess with the zombie dog, but they could mess with the zombie cat because of how I gave away that address. So right here, I've called to increase the defense level of the zombie cat. And I've called to increase the attack power of the zombie dog. Only one of those 2 things is going to change. Let's see which one it is. And it's going to be the cat. But let's see it happen. All right, so if we look down here, gotta get the video out of the way. All right, so right here, if you notice the zombie cat initial state has a defense level of 0, okay? And after I called increased defense level, it went to 1. All right, well, look at the zombie dog. It had an initial state attack power 1, Even though I called increase attack power on it, it actually stayed at 1. And it's not because the method messed up. The method does its thing. The difference is this. When I'm calling print game state, I'm not printing the state of these objects. I'm printing the state of fighter cat and fighter dog, the objects that live over here. So when I increased the attack power on zombie dog, that had nothing to do with fighter dog. They're two different things. Okay. But it did have something to do with fighter cat. Fighter cat here and ZC here are the same cat. Okay. Different names, same cat. Because of how I gave away that memory address, I was actually able to make changes within the battle arena from an external class, even though this was a private object. So remember, when we make an object private, we're trying to restrict its access to the declaring class. That's like our goal. But since I just took the address from that external class object and I created an alias to it, that was really risky because what that meant was is now it was like I had two paths to the same place. One of those paths is here in the battle arena, but the other one is over here called ZC. And so ZC was actually still able to make changes to that private object from this external source. Again, this is some pretty high level stuff and it's pretty rare. I don't think we're going to like run into this a lot, but eventually this is a concept that we want to make pretty good sense out of, like when we get to learning how to pass by value, pass by reference. So it's something we'll come back to. I know it's confusing and I'll try to explain it to you more as we go on.